Hello and welcome. Just a real brief video to say hello from Thailand and kind of bring you up to date on what I've been doing. I should have made a couple of other videos. I've been in fan repair mode. Fixed this one for one of the friends of Jip. I had to replace a motor capacitor. Had those at the local home improvement store. And got that up and running for her. Then the kitchen light went out the other day and took down the panel. It was a series parallel string of about 40 LEDs. And using my little travel meter here, I was able to put it in LED mode, find out which LEDs had gone open and just jumper them out, put the light back in service. Since they're current regulated, removing, one pair of the LEDs isn't going to hurt anything. It's going to automatically compensate. Should have taken a video of that, but didn't think of it in the heat of battle. And then this fan was dead here in the shop or in the little workroom. And I opened it up. Electronic controls. God, I love Japanese engineering. This thing is just so sweet. Had a fuse. The fuse was good. Tested the cap. Again, with my little travel meter here, this thing goes everywhere with me. I did a video on this guy. It's just a cheap, inexpensive meter, but it's got just about all the functions you need on the road. You can test capacitors, resistance, continuity, voltage, current, AC and DC. And it fits, easily into the suitcase. But check the fuse, check the cap, and then found this resistor, 100 ohm resistor, metal film resistor, with a hole in the side of it. And it appears just to have been a failure of the component. I went back, checked the capacitors, checked the diodes, everything else in the little power supply circuit here seems fine. So went online and got some 100 ohm resistors coming. We'll replace that and this thing should be back in service. But what triggered me to make this is it's always such a pleasure to work on this early Japanese stuff. This fan's fairly old. It is just so well laid out, and it's marked triac low, triac medium, triac high, triac switch. It's got the IC marked for the little microprocessor that's on this side. It's got the crystal marked with the 4 megahertz. It's got everything laid out. All the coloring, all the color codes for all the wires. You could completely disassemble this thing and put it all back together. And everything you need to know. Of course, when I opened it up, all the buttons fell out. That's not a big problem because they're marked here, as well as, if you look carefully at these, this is again another case of Japanese engineering. These are all keyed. They can only go in one spot. So when you put them back in the housing you can see has upper right, you can see a double divot there. Upper left, you can see a single one. So it's immediately obvious. So these are the 2 keys that go in there, or 2 buttons that go in there. So I'm waiting on the resistors. They'll either show up or, I ordered several just to have a few extras. They'll show up either today or tomorrow, and we'll put those in. Of course, I leave this here, but I've got a little soldering iron in there and, a few other basic hand tools. But this little guy has been a savior in so many situations. Again, I did a video on this a long time ago, and it's not, it's not the greatest thing in the world, but I'll tell you what, it has gotten me out of trouble so many times here. Okay, we'll pick this up again when the resistor shows up. We'll solder that in. Okay, my resistors came in from Shopee, one of the local mail order places here. The girlfriend has a subscription to. I don't know if Shopee is just in Thailand, but I imagine these come from the usual suspect, the big C. They look good, but let's see if they're actually 100 ohms like they're labeled. I imagine they are. We just don't know what quality. And we got 98.4, close enough. Close enough. I just watched one of the cats jump on those boxes, jump on the window ledge behind that shelf, jump up to the shelf, jump to the top of those chairs, jump to the beam, then jump on that little ledge and did a balancing act along there, went inside of where the karaoke bar, our karaoke stage used to be, walked all along here, up here inside of this, all the way down this ledge, jumped down on this ledge, traversed the whole length of the place, back up there, back on the beam, back to the chairs, back to the shelf, and down. Unbelievable cats. And what she was doing was chasing what's called chinchokes, little tiny 4 and 5 inch lizards that run around here. They're everywhere. Absolutely harmless. They just eat insects. But, she chased 2 or 3 of them, but they got away. All right, I'm going to solder this in. I can't hold the phone and do the soldering at the same time, so we'll solder this in and see what happens. Not sure if that last video bit got recorded or not, so I'm doing this again. This is my soldering iron. Picked this up at the local home improvement place for about $3, I think it was. And the tip has again come loose. This nut comes loose all the time. 30 watts, 130 watts. 30 watts when you plug it in, and when you pull the trigger it boosts it to 130 watts, but they tell you not to do that for more than 30 seconds. But it got the job done. We've got the resistor in place. I stood it off the board, give it a little more room to dissipate heat. I don't think it gets hot because the board's not discolored. I think that was just a faulty resistor. When they laser trimmed it, may have trimmed it just a little too thin in one spot. But at any rate, we'll trim this up, plug it in, and see what we got. Okay, moment of truth. We've plugged it in. We're going to turn on the power and see if it goes bang. And as Big Clive likes to say, it's far more entertaining if it goes bang. So I'm going to push the on button here and see what happens. Now, I don't know if this will wake up in swing mode. If it does, this thing's going to swing up and down and try to jump off the table, but we'll see what happens. Okay, that resistor didn't last. Now, I checked all the other components in here, and it showed no short circuits whatsoever with this guy. So evidently whatever's breaking down is breaking down at high voltage, but not breaking down with that. So we'll have to dig a lot deeper here. What's surprising is the fuse doesn't go. That resistor burned up. Good thing I bought more than one. Okay, this is where our resistor goes, here to here. This is our line coming in, this blue and this brown. And when I measure from here to here, which would be the return back out, this measures megohms. There's no short showing. It's in the megohm. Well, actually, it's 1.8 megohms. So whatever's happening happens when the thing powers up and the voltage gets above a certain threshold here. Something's turning on, and so we're gonna have to dig a little deeper. I'm not sure what's going on. I thought just the resistor had failed, but you saw from what just happened, obviously when power is applied, something bad happens. So we're going to go through and take another look at everything. We got what I think is a little buck regulator here. There's an inductor, this chip, these 2 caps. I'm pretty sure the buck regulator circuit. Sure wish I had access to everything in my workshop. But we'll puzzle this out as we go. I'll get on the gargler, as Abe would say. See what the pinout of that chip is. But, we'll bring you along for the journey. All right, this is interesting. These two diodes tested good initially. This one's open now. This one's fine. This one's gone open. These two caps tested fine out of circuit. When I check them in circuit, they're still behaving as capacitors, but the resistance drops all the way down to about 10 ohms. So something associated with this, I think. I don't know, I'm gonna have to draw the schematic out, see where this inductor is in circuit. But this diode has gone open. So I'm gonna have to order some diodes. Maybe this chip, just to be on the safe side. If I order everything in one fell swoop, I just retested this cap, this cap, this cap, and this cap, and they're all fine. This stuff's all associated with, you know, the switching and the circuitry. This is just the power supply section here. So I'll see if I can get a hold of this chip and this diode and get these ordered. And we'll pick it up from there. It's going to be quite a trick desoldering this. I'm going to have to see if I can get some desoldering braid as well. Boy, I miss my workshop. It'll be good to be home next month. My helper is joining me here. My helper likes to keep the bench clean by sweeping all my tools and small components onto the floor. There go my capacitors. You're not much help. You know that. Yeah. I don't know. Cats. Alrighty, here's where we're at. The two input filter capacitors are absolutely fine. When you check them with an ohm meter, you can see the charge, and then, you know, the resistance falls away as they charge up, or the reading falls away. Putting the meter in capacitor mode, they measure exactly 4.7 microfarad like they're supposed to. I'm absolutely certain they are fine. The switching chip, however, is dead. That's an LNK302PN. The PN is just a variation of the TN. And they have nearly exactly copied, I should probably, you know, they've nearly exactly copied. Here I am shooting vertical video, it just dawned on me. I'm not used to shooting with a camera. Sorry about all the racket. I've got the door open. It's hotter than hammers of hell in here. And being a weekend, all the local Harley guys are riding back and forth. There's a massive Harley contingent here in Pekchong, Thailand. They often go by in groups of 20 and 30. They've almost absolutely copied to the letter. You know what? I'm going to reshoot this. Okay, I realized I've been shooting vertical video. I'm not used to shooting with the phone. I'm used to having my camera. Never even gave it a thought when I started this video. Apologize. Anyway, the switching chip is dead. This guy right here. That's an LNK302. Mine's a PN, just a version. It's one of the versions of this chip. And they have just about copied the data sheet. I mean, it's the same circuit. A pair of 14007s, 1N4007s in the front end. A 1N4007 they've got in here instead. There's a Zener diode across the output, a 5.1 volt Zener. All the diodes appear okay. When I check them in diode mode, I get pretty much the same voltage drop across all of them. The Zener, of course, I can't measure correctly. I don't have a curve tracer, and this unit only uses 3 volts, 2 AAAs. But I get 0.4 volts one way, and it shows open the other, so it's probably fine. But Zener diodes are cheap. It's a jelly bean part. I'm going to order one. I'm going to order a couple of 1N4007s. Actually, I'll replace all of them because they've been stressed. All the Harleys are flying by. Sorry, the door's open. Massive Harley contingent here in Pak Chong, Thailand. Hundreds and hundreds of them. They go by in packs of 10 to 30, depending, you know, what's going on up in Khao Yai National Park. Where were we? Oh, the capacitors, the input power supply capacitors are absolutely fine. That's the pair of capacitors, 4.7, 4.7. They measure 4.7 on the money. Nothing wrong with them. The diodes measure fine in using diode mode. Slight, you know, tenth of a volt difference in the forward voltage, but I'm probably going to change them because when I put it in ohm meter mode to check the diodes, I'm getting odd readings. So just to be on the safe side, I'll replace all the 1N4007s. There's 3 of them, 1 here, 2 here. The Zener I think is okay, but I'm going to replace it. They're cheap. But definitely the LNK302 is dead. This chip, from drain to source, it's a dead short in both directions. So that chip is definitely fried. And again, jelly bean part, I'll get one ordered, drop it in there. My one concern is the microprocessor that's back here. And that is what they call a proprietary microprocessor. It's an 8-bit microcontroller, 64K, with outputs that'll handle, depending on which output, 15 to 100 milliamperes. That's used to turn on the transistors for the fan speeds here. I don't have a hot air gun. I suppose that if I, in a pinch, you know, I could lift one pin at a time and solder another chip on, but I've got no way to put a program in here, nor do I have any idea what the program is supposed to be. It's a programmable chip, and if it's dead, it's dead. That, as far as I'm concerned, if this project is finished. But I'll keep my fingers crossed. When I measure across VCC to common in the diode mode, it shows open one way and a very high voltage drop the other way, and on the ohm meter reading it's several thousand ohms, so I think it's probably okay. I'm hoping that it just didn't pass 230 volts into it though when the chip went short. But the fact that the Zener diode here appears intact, I got my fingers crossed. We'll see what happens. And again, I apologize for the beginning of this being shot vertical video. I'm not used to using a phone, and having the camera, it's you know, you don't give it any thought. The camera's on a tripod. It shoots in the correct aspect ratio. So we're going to get some parts ordered up here. I managed to find most of the parts the cat had scattered on me and picked up my tools. It's off chasing lizards somewhere. So we'll get back to you very shortly. For you, it'll be a second or two. All right, my parts are here. It is Sunday, March 24th, 8 a.m. Thailand time, which means it's Saturday, 9 p.m. New Hampshire time. We're this time of year 11 hours ahead. When daylight savings swings the other way, it makes it 12 hours ahead. We have some welding treasure, soldering paste. We have what I hope is genuine Hakko solder wick. Some 5-volt Zeners, 1N4007s. Of course, I had a bunch of the 100 ohm resistors. And our switching chips. Now, when I ordered these, the photograph that they showed of the chip that was in the picture was a Power Integrations. This is not. This is a clone, copy. I just hope it's real. In fact, I hope the Zeners are real, and I hope the 1N4007s are real. You never know what you're getting over here. And now I'm second guessing whether I should change all of the diodes or not. And take a chance that these components are real. I think I'm going to get this chip out and think on it while I'm doing that. Use my new solder wick and my solder paste here, and we'll get this chip replaced with the clone AK, or hopefully not counterfeit chip. Put everything back together and we'll see what happens. And again, I've got crap load of diodes and an extra chip. I bought 2 of these. I think everything here totaled up to about $5. No, excuse me. This was $3, so it was more than $5. But you know, these were like $1.50 a piece. We'll see what happens. But I can't hold this phone and do my desoldering and soldering at the same time. But I'll bring you back when I've got it done. All right, here we go. And we have another visitor in the shop. These guys are running all over the property. Let's see what he does. Usually they curl up. No, this one's a braver one. He's not going to curl up. Usually they curl up into a coil. They eat debris from dead vegetation and poop out fertilizer. They're harmless, but I don't want him in here because he'll die. So we'll send him out the door here. There, he's trying to get back on his feet. There you go. You're outside. Sorry about the traffic sounds. It was 38 degrees yesterday, 100 Fahrenheit. And it's already 80 degrees at 8 o'clock in the morning. Trying to get some cross flow through here. And here comes my helper. I don't need you. Go away. Okay, let's get to work. Put everything in a tray. Hopefully it'll stop this one from sweeping everything onto the floor. He likes to come up and bat stuff around. Yeah, you're not very helpful. Okay, here's where we're at. New resistor, new IC, and source to drain is in the mega ohms at this point. There was a 1N4007 here. These are also 1N4007s. These measured a forward voltage drop of about 0.57. That's what it was, 0.57. This one measured a forward voltage drop of about 0.4. All of these measured 0.57. So I replaced this one. This is a new Zener. The one that was in there was a 0.5 watt. This is a 1 watt, 5 volt. When I lifted one leg of this to give it another check, when it was hot, after I lifted it, it was showing conduction in both directions. One way was about 0.4 of a volt, the other way was about 0.7 of a volt. Now that it's cooled down, it's only showing 0.7 in one direction. But I suspect that was on its way out. These new ones measure 0.7 one way and open the other. The capacitors are back in. And we're about to put power on this and see if we have more fun and games with smoke leaking out. So let me get this plugged in and we'll get the camera turned on again. Oh, and just to add to the fun and games, I don't have my magnifiers. So I'm having trouble seeing as it is. And then one of these LED lights up here, that guy has decided its power supply is about to leave the chat. Every once in a while it just dims out, dims out. It's been fun. I wish I had my curve tracer. I'd feel a lot more comfortable if I could run these diodes through the curve tracer. suppose I could buy a bunch of flashlight batteries and stack them up, put a resistor in series, and measure the voltage across those diodes, but I'm not about to do that. I've put enough time and effort into this as it is. I do have an extra chip. I do have a bunch of extra diodes. So if it goes bang again, I've got one more shot at this. Let me get it plugged in. Alright, it's plugged in. We're going to hit the switch. And nothing exploded. Let's see if the on button works. And it appears not to. So my guess is the microprocessor's dead. So after all that time and effort, it's still dead. At least we know the power supply is fixed. Let's see if let me see if I can find the output of this thing. We'll check the voltage. Okay, that's the end of this journey. The IC here is getting warm. The switcher is bloody hot. The IC is showing a few millivolts across its VCC and ground or common. So when the power supply failed, it obviously took this guy out with it. I suppose I could put a rotary switch in here and turn these transistors off and on pretty simply, but I don't think it's worth the effort. It's done. I gave it a valiant try. You can't win them all. If I was at home on the bench, I could dig into this a little further, but again, I've got no way to program that chip and wouldn't even know where to get it. It says it's proprietary. Thanks for riding along. I'm the radio mechanic. Sometimes you're the bug, sometimes you're the windshield. Catch you later. Okay, I just can't or couldn't leave this thing alone. I came back out here this morning, took another look, and I removed this jumper, which is the positive rail going to the microprocessor, and turn it back on, and I still only got like 10 millivolts on the positive rail. I pulled the filter cap again, checked it again, nothing wrong with that. These two diodes are new. I'm wondering about putting the originals back in just to see what happens, but I got a feeling I've been sold a bogus chip. You know, where they showed me one manufacturer's logo, but the chip I got has a different one. Hard to say, there's not much else in the circuit. Some passives, this transistor's connected, but that doesn't get warm at all. The only thing that gets hot is that IC. I'm going to throw the two diodes back in here that were original and see what happens. But I think I've eliminated this as being the current drain, because this jumper here, this positive rail comes down, goes through this 0 ohm resistor and back up here to VCC. And with this jumper gone, I've still only got about 10 millivolts. We're going to keep digging. I'll let you know what we find. Oh, and I forgot to mention, went online yesterday and found a replacement board, the whole board, for 237 Thai baht, just over $7. So we ordered that. Now, it's an upgraded version of this. All of the power supply stuff, the fuse and this capacitor are on this side, as is this resistor, but everything else that's in the power supply is on the other side. Same LED layout, same button layout, same pinout over here, but it has extra connections where you can see there's outlines for plug-in connections for a slightly different model. But the one I ordered has all the solder connections that this one does. So we'll be able to drop that in, but I am just curious now. I have to figure out what is dragging down. And again, I'm suspecting I've been sold a bogus chip. but I've got more in parts now than the whole board cost. But being a curious type, I've got to keep picking at this until I figure out what the issue is. Okay, looking back at our schematic here, there's our switching chip. Now I've just gone through and I've checked this capacitor not shorted. This is not open. Now I can't measure what it is. My meter doesn't measure inductance. I could do that if it was on the bench at home. But it's about 1.2 ohms DC, and I took it out of circuit just to verify. So what I've got left is this diode. This one I know is good. What I've got left is this diode. So we're going to pull that and put the original back in. And if it still doesn't run, if there's still no juice, I think I've got a bogus chip. Okay, no dice. The old Zener, which I'm pretty sure was dead anyway, has disappeared. Cat probably helped me out. Swept it on the floor somewhere and it's gone. At any rate, I'm positive that chip is dead. I will wait for the new circuit board to arrive. We'll install that, get the fan going. And I'll take this thing back home with me and run some of these parts through a curve tracer and see if I can figure out what actually happened to this thing. But yeah, all the resistors are good, all the capacitors are good. It's got new diodes. And again, I think I've been Chinesiumed. I think I've got bogus chip here, counterfeit chip. You could take a 555 timer, cut off one leg, and re-etch the part number and so on, you know. It is what it is. I'm not going to pull this one out and try the other one. I'll wait till I'm home. Have this on the bench, and I'll order a genuine one of these and probably get this thing up and going as a spare. Okay, the new board has come in, and as you can see, it looks quite different from the original one. It still has all of the marked connection points for the wires, but it also has the option to install some headers, so you can just simply plug things in. We'll flip this over and you can see this one has a lot of surface mount on the back side, whereas this one, oops, I got my fat finger in the way again. This one only has the microprocessor here, and this one has, of course, a much smaller surface mount microprocessor, but all of the power supply components, solid state stuff's on that side. Still has one coil here, but the same LED arrangement, same button arrangement, same hole pattern. I have no idea if this is the real deal or if this is a Chinesium copy. Carries the same part number, but I can't find any manufacturer's mark, but it's fairly well laid out. It's got all the component values on it, so I guess there's a possibility it's the real deal. We'll get this installed and see where we're at. Okay, moment of truth. Is this the real deal or does it go bang? Turn on the power on. Oh, we made a little beep. That sounds promising. Let's see, on speed. Ah, the motor's spinning. Low, medium, high, okay. And let's see, timer swing. This should make it swing. Yes, it does. I stopped it so that it wouldn't yank the board away. This should be off. Oh, this is timer. 1 hour. What is this? 2 hour, 4 hours, 8 hours. Off. And main off. Okay. Now we have not given up on this entirely. We're going to take this home where I have a magnifier and I can see what I'm doing and I can get my hands on genuine parts. and a curve tracer, and we'll find out if we can bring this one back to life just for giggles. So I guess that's it for now. We'll be home. This is, what's today? Today is the 25th of March. I'll be home 24 April 2024. And probably pick up videos from there. For now, I'm the radio mechanic. This ran a lot longer than I thought it was gonna, but hope somebody found this at least partially interesting. There's not much I can do here without my full-blown shop. Take care. See you soon. Stay well.